Hey guys, how are you? Welcome to the pitch session. Yay! Woo! So after, 2 days of hacking, I hope you've got some great ideas. Is it looking good, yeah? Yeah? Cool, brilliant. I hope you've had a great time here in Google the last couple of days. I tell you, we were just so amazed with the hospitality, the food, just everything's been absolutely amazing. And thanks to all the team, the volunteers, and everyone for spending their weekend here in Google over the last couple of days. Thank you so much. Thank you. And also, I just want to introduce the judges. They're here at the very front. They're not too scary. They're going to be really nice. Isn't that right? Yeah, we got Karen, we got Davida, we got Martin, and we've got Natalie. So you guys would have met them over the last couple of days. So they're going to be really nice. And make sure you keep your presentations to 3 minutes. That's the number one thing that we ask. So yeah, we're running really tight on time. But what we're going to do is we're going to call up the first team, and you're going to get your pitch. You've all practiced here, so you know the layout. And the microphone and all that's over here. So I'm going to call up the first team. It's Aeralytics. So if Aeralytics want to come up. Thank you. Woo! You all set? Yeah.
Hello. Thank you very much. So we are Team Aeralytics. We're a team of consultants, ex-consultants, and housemates of consultants. And our idea, our demo, is called Schooling Safety. So the problem statement that we're looking to tackle here today is that of asthma. 22% of children ages 6 to 14 will have asthma. We've got 9% of those childhood cases linked to fuel fumes, and nearly $500 million of annual costs to the state in 2017. So what we're going to try and do is see if we can combine data sets around schools and air quality to try and give specific targeted interventions. So what we did, we took 2 data sets. We took the climate air quality measurements and some geocoded primary schools. We then applied exclusions and rules. What we looked at is for every school, we looked at a 200-meter radius and looked at what points there were within that radius that the cars had gone past. We excluded things like school holidays. We then started looking at features, things like seasonality. And then, apart from seasonality, we also looked at trends within a given day, so things like drop-off and pickup times. And then what we wanted to come up with was a list of target schools with particularly high NO2 or PM25 levels. So let me show you the demo. So this is the demo for Schooling Safely. As I bring in the data here, what you're going to start seeing is all the different schools that have the kind of the air quality measurements around. They're sized by the number of pupils in each school, and you can see the color here corresponds to the different NO2 levels. So there are 2 schools that have NO2 levels exceeding the EU's guidelines, and another 10 that are approaching that. And really what you see is that kind of concentration in the inner city. Again, we could look at things like PM2.5. Interestingly here, pretty uniform across the city, but very high up on that kind of northeast coast. And we've also looked at things like trends at different times of day. So this is from 7:30 to 9:30, kind of the school run in the morning and the school runs in the afternoon. So what did this data show us? What we saw was high NO2 in the inner city and highest PM2.5 in the northeast. And these are our 10 schools that we believe are the ones to target from that. And I'll come back to the one at number 1 for a moment, because it's got a very high PM2.5, and we'll explain why. Before I do that, I want to talk about some of the targeted interventions that that we could consider. So we've got this kind of new idea, and we've kind of patented it already. It's around the next generation sensor. It's called Not a Climate. So apologies for everyone else who was thinking about that. But in terms of more practical solutions, we might look at implementing traffic calming measures around schools. There's a few schools that had piloted this. Actually, that picture was taken at one school that was piloting this in inner city Dublin. Things like planting more evergreen trees and shrubs, so those kind of trees with leaves that can kind of trap those emissions. Limiting construction near schools. So the school I mentioned earlier on, that's got really high levels, you'll see in a moment, we actually have a Google Earth video of it. It's right next to a construction site. So what are the effect of those construction sites on schools is almost a project into itself. And finally, we're looking at external, air quality measurements, but we might look at how can we change things in classrooms? So can we bring in HEPA filters in these classes? So thank you very much. And what I'm going to leave you on is a video of the school that's highest ranked for pollution that we found in our data. So we put this into Google Earth, and we'll start zooming in now in a moment, and you might see something interesting. We see children playing on the left-hand side, and we see a very large construction site here on the right. So this is the school that our data identified as being the one to intervene. Thank you very much.
That's great, fantastic. So, loads of new insights there, and actually ties in with a lot of the work we're doing on citizen science and working with schools. So thank you very much, guys. Really, I think a powerful presentation, great visuals, and just kept the time as well. So really good. Thank you very much, guys. Okay. Thank you. So we're going to ask the next team. We're going to, what? No questions. Yeah, we're going to just move from one to the next. Yeah. No, you're okay. The judges.
Afterwards.
Yeah. So the next team we're going to ask up on stage is AirPact. So if AirPact want to come up now, thank you.
Hello everybody, we are Team AirPact. Maybe the small hitch. We are still Team AirPact. 1,300 people prematurely lost their lives due to PM 2.5 pollution in Ireland in 2020. So what we are looking at is vulnerable groups need practical information to protect themselves and live with health and well-being from PM 2.5. And what we have come up with is a hyper-local solution where people would know when and where to go out in their locality. So what we see here is a school zone in Dublin and different streets in Dublin. Say, for example, we look at the last image that we see is Phoenix Park on a Thursday afternoon. So there are many children and families going out to Phoenix Park at that particular time. We could tell them when to go and when not to. And this shows, again, the evolution of air pollution during different times in Dublin and showing which are the pockets to avoid. So how can our solution inform future policy? First of all, using our maps, we would be able to say how air quality is linked to health. So basically, we have used the total health data from CSO to map the two. And then we could then generate health matrices. So for example, if there is an active travel intervention in Phoenix Park, then we could see over a period of time what is the impact of that active travel intervention from our app. And then this could actually inform community cohesive design in Dublin. And who we are. So we are a team of data scientists, engineers from all across Dublin, of all age groups, who work together to create an impact using air quality data. So say AirPact. Thank you.
Thanks very much for that. So we're going to go on to the next one. We've got Cloud DevX now, guys, if you want to come up. Cloud DevX. I'm interested to hear all the different names of the teams.
Hello, everyone. Hi, so I'm Tripti Unitan.
And I'm Bhumit Kaushik.
And so we're going to be talking about urban planning. But before that, can I just see a show of hands of how many people here might be below the age of 18 or 18 maybe? Yeah, no, yeah, okay, one, but okay, so we thought we were just the youngest, just to clarify. Anyways, so we'll be talking about urban planning. So urban planning is like a situation that happens a lot, especially back home in New Delhi. We have a lot of air pollution over there, which affects a lot of people in terms of health, well-being, and social life. So we're going to show you like what we've come up with.
So if we talk about data, when we looked at the data, we got to know that it was unsupervised data. So we went with interactive scatter plots. Then for prediction, we went to k-means for clustering. And then to visualize data, we went for Streamlit. And also we created maps through Folium from Python. And we came up with
The variables of NO, NO2, and CO2 being most visible in these areas. And in the next scatter plot, you can also see this is where the roads are mostly driven, especially through these areas. So two of the main roads that are mostly affected by these pollutants are Eden Quay and Yeats Way. So without any further ado, we'll go on to the solution we've come up with. Actually, the problem, sorry. So the problem of urban planning is mainly the air quality, and the influence of poor air quality happens between 45 to 50 of nitrogen dioxide that can be seen going from the quay all the way to the port. And so we've come up with the solution of Green Route, which is the solution name we've come up with, which includes three main factors. Firstly, being housing. So housing includes Green Buildings Initiative and Green Rooftops, where we believe that Dublin City Council can perhaps collaborate with Irish Green Building Council to produce housing which is more eco-friendly and provide an indoor quality license for people who meet these criterion in terms of just using eco-friendly substances in the house, such as solar panels, and also the implementation of air cleaning pavements, considering the fact that we all know that the Irish weather is pretty bad and it rains quite a lot. So the air cleaning pavements would probably have permeable pavements which allow the rain to like seep through the ground and prevent air pollutants from going into the atmosphere. Second, the transportation factor. So we've come up with an odd-even license plate concept where basically vehicles with a license plate that's an odd number would go out and drive on certain number of days, while an even number license plate would go out and drive on another number of days. So this basically improves public transportation and reduces like congestion of traffic on the roads. Lastly, rewards. So obviously, if everybody has a motive, then they would want to do something. So rewards in terms of transport tracking feature could be a collaboration that is done with Google Maps, where basically we track how a person travels, whether it's in terms of train, bus, or cycle, and they have to upload a proof. So like if you know of the Bleeper app, they do a proof. So like whether you have your tickets or simply a history of your Leap cards, we're able to track the way you travel, whether it's eco-friendly or not, and accordingly give you back in terms of incentives, which could be done by tax credits or grants. So to conclude, we would just advise you and hopefully hope that you use Green Route as the next best alternative to help us achieve the topmost air quality in Dublin. Thank you.
Well, guys, that was super. So that's great. Now next, Data Science Wizards. So Data Science Wizards wants to come down. Thank you, guys. That was great.
hello all. Good afternoon to one and everyone present here. So we are a team data science wizards, highly skilled in artificial intelligence in the data science space. We've also worked in the past with environmental data and with air quality that has piqued our interest to be here at the hackathon today. Sorry. Can you change the slide, please? Yeah. So this is just the code that we have. So the air we breathe is a shared resource, and the impact of it on climate change is also a shared problem that hence requires a shared solution. So tackling this, we've devised for a deep tech-based solution that essentially is used based on a predictive model that will help in improvising the air quality. The main causes for nitrogen or air pollution or poor air quality is generally targeted with travel emissions and with respect to construction. And the impacts of it are, of course, something like global warming, and of course, we have the poor health and also industrial-based problems. So moving on. You can
Okay. Great. Thank you, Rahul. So we churned both the data that we have received, the descriptive data basically, and the per second data, and we came up with we followed the life cycle of analytics, started with the descriptive analytics that helps us to find the correlation between the important pollutants, followed by what exactly the distribution looked like, because we wanted to go from the descriptive analytics to the predictive analytics and give some prescription on top of that. So this is one of the very important aspects we saw that while working on the descriptive analytics in a particular areas, when a vehicle moving within the speed of 10 to 15, they are emitting more pollution as compared to when they are going with 30 to 60, something like that. So you can see a peak when it is close to 15, and the peak is going down exactly when something between 30 to 50. This is the K-means clustering algorithm that we have worked upon that has given us the clusters where exactly the red areas are, where is green area, and where is the amber areas. And based on that, we came up with this final chart that can help you to identify, given the name of the area, what exactly the risk level of each of this pollutant is. Like, what is the risk level of NO2, what is the of CO2, and so on. So we have created one small demo as well where you can, it's just Angular-based demo where you just upload the data. Yeah. So this is based on the predicted areas that we had. The model predicted that in certain areas of Dublin, the NO2 or the PM2.5, the emission is going to be really high. It will show you the same area in the map as well, where it is predicting that it is going to be high. And in the same way, it goes for the NO2 as well, where the area is really high for the NO2 as well. It shows you that in red, and the same followed by in the green as well. So this is for the PM2.5, we can see. And the same again, like one of the areas in Dublin where it will show for NO2, it was initially in red and then followed by the green. So basically, this area has been predicted by our model, which is predicting correctly as compared to what data we have received. We have validated it with the same. Yep, I think that's it. Thank you, guys.
Thanks so much, guys. They're definitely the coolest Google Earth videos so far anyway. Amazing. Definitely not ChatGDP is the next one. What a cool team name. I hope your presentation is as cool as your team name.
It does work. Found out. Okay, so we did hyperlocal air quality, specifically on Dublin hospitals, so looking at that. So the problem with air quality in hospitals is twofold. So if you're in the hospital, you're already sick. So if you have COPD, asthma, or another respiratory illness, it's going to make it worse if you have more particles coming in. Secondly, we know that particulate increases hospitalizations. So the problem in Dublin hospitals, if you've been to one, is they're overcrowded. There's a long wait time for ED. So we're saying if you can decrease the pollution, you can make their improve their outcomes, excuse me. Also, we know that hospital filters catch PM, but not NOx. So we focused on NOx for a lot of our investigations. Oh, excuse me. So we looked at 3 different hospitals. So we looked at St. James, Mater, Vincent's as some of the biggest in Dublin, as well as the other ones. And as you can see, 3 of the 4 had exceeding the WHO guidelines for the NO2 levels. So we wanted to understand why is this and what's causing that. So we went into data science and we looked at a lot of the different correlations. We looked to see what would really affect it. What we found was that the time of day was one of the most important variables, with 9 a.m. and 5 p.m. being the most. Also, we looked at the map of interpolation. So as you can see here, we have the roads, which was initially created, but we saw if you're in a hospital, you're not going to be on a road. You're going to be in any other place. So we interpolated all the data to create a map that's based on every single spot in Dublin, and then looked at the hospital areas specifically. So as you can see, by the Mater Hospital, which is the biggest hospital in Ireland, why are the NOx emissions so high? From the first slide, it's one of the highest ones. This is the hospital right here, and you can see that there's an intersection that's purple and red right next to it. We did this heat map, and you can see as well it's in the upper left. So we were trying to understand why is it 3 to 4 times higher NOx emissions in this area. And we looked at this intersection, and we went there as well, and we found that it is a special intersection because it is a 4-way pedestrian crossing. So every single car or bus that goes through this intersection is forced to idle. You can see some of the cars here, and you can see this yellow in the middle, and that's on a lot of intersections. But we also looked at what are some of the other special intersections in Dublin.
So what we find is wherever there is like traffic lights and that yellow intersection, you will find high emissions of NO2 or NOx. Slide. Like we have examples here. And next slide. So what we did is we collect all the traffic light signals data, and we plot it with the pollution one, and we can see it is highly correlated. So what is happening here is, so if there is a yellow cross section or a traffic light signal, so the cars will go and the engine will keep on, but the cars are not moving. So they are producing more of the NO2 gases over there. Next slide. So we also look into the hospital, which are green. So there is St. James Hospital and St. Vincent Hospital, and we find the reason is near the St. James Hospital, there are not a lot of traffic, and there's a Luas line going next to it. So that's why a lot of people are using that instead of going with the cars. And near St. Vincent Hospital, there is a very big green area, which is a golf course, so which is really helping him. So what we come with like few solutions. First is like, so in Dublin, basically they use like a Sydney SCAT system for the traffic, so we can reprogram it or put some new one, because it is given that like Dublin is the 3rd slowest city in the world for the traffic movement. So there is also a very good research done by some scientists in China. They shows that if you can use the political. Okay, let's go with it. Yeah, 4 ways. And you can see that the low bus emission zone, and we can use a certain species of the plants to improve that. And we can also use some strategic building heights around the city to do that. Yep. That's our team here. Thanks.
That's really great visualizations as well. And I think, Martin, some interesting things there on traffic lights. I know Google's doing some work on optimizing traffic lights as well. So thanks so much for that, guys. Hack the Haze, I think, is next. You guys want to come down?
Hi, everyone. We are Hack the Haze. We're a team of computer science students from Trinity College Dublin. I'll pass you on to my colleague Fionn, who will introduce you to the problem.
So one of the most striking things that struck us when we were looking at this data was that there's a lot of air pollution in Dublin that pedestrians walking around the city simply don't know about. And the problem we identified is that these so many pollutants have adverse effects on public health, they increase mortality, and that there's a lot of vulnerable people in Dublin who would be affected by these pollutants. We wanted to identify a sort of general solution, but that would also work at the local level. So I'd like to ask you to spot the difference between these 2 pictures I'm about to put up. So this one's a Google Maps route, 31 minutes, nothing special. and then we see this next one, it's 36 minutes. Most obvious difference, obviously the second path seems to take a little longer. But there's actually a little hidden difference in there, and that is the air quality of the two paths. If we look at the second path, we can see there's actually a big difference in the air quality, so much so that there's a 60% reduction in the average NO2 intake for only 5 minutes of extra time. So this is our solution to our little problem, which is alternate routing. You could look at Google Maps and add a little extra feature that allows you to take air quality into account when you're choosing a route to go to. Pedestrians often are most interested in the shortest path to any destination. But what if more health-conscious pedestrians had the option to include this sort of data to make a more informed decision as to what one they want to take, and then allow people who maybe wouldn't otherwise think about this to take it into account when they're planning their routes? This is a little proof of concept of how it might work. You have a green path with a little heart indicating that there's better air quality along this one. There's no place for complacency when it comes to air quality. We can see that the mortality rates for circulatory and respiratory illnesses, they've had an overall varying downward trend, but we know that if we implement something like this, we can really impact it and drive those trends right down.
Our solution is easily integratable and scalable. First of all, as you saw earlier, it can be easily added as a little extra add-on to something like Google Maps with the green heart. Also, it's scalable. The more granular data we have, the better predictions we can make with these models regarding the shortest path and the cleanest path between 2 points. It is particularly useful for vulnerable people, such as people with asthma or other respiratory illnesses. And it's integratable with multivariate data sources, such as public health data, census data. What data sets did we use? In addition to the Project AirView data sets, we also used the CSO data on the mortality rate on respiratory, as you saw earlier. And finally, what are the next steps that we can take? Well, first of all, we can do more research into the actual optimization algorithms that we use. We can incorporate more granular data, as you saw earlier. We can also incorporate live data, such as construction sites or meteorological data, to improve the accuracy of our predictions. And once the full 2022 open census data rolls around later on this year, we can incorporate that data as well to better quantify the benefits that our model can bring. That's about it. Thank you very much. Thank you.
Thanks, guys. Real simple ways of integrating data into Google. I think you guys hopefully looking into that into the future, maybe, Karen, yeah. So thanks so much, guys, and great structure to the presentation there. So the next team is Net Zero. So we want Net Zero to come down.
Okay, we are Net Zero. We're here to look at the Google air quality hack. So would you start the next one? So first of all, we're just a new collaborative team. We come from different parts of the world. Just the next slide, please. Our problem statement is AirChalk. We're a new dynamic new company, and we're kind of analyzing air quality in kind of a busy city. And we're looking at it to try to look and tie into Dublin City Development Plan as well. Next slide. The data that we used was an AirView Dublin roadmap, where we used DAF listings, Dublin linked government data, and Project AirView. This is just some of the resources we used. This is just some of the impacts on air quality that we used as well, and the nitrogen dioxide and general health effects of PM2 in the air as well. Our innovative approach was looking at how carbon dioxide will affect humans on residential properties, so we used DAF listings, and our approach was looking at data, awareness, and behavior change. And I'll give it over to Sean to talk more about it.
Yeah, so we have, can you go back to the slide, please? Yeah, so the key is we have the data now, and our ultimate goal is how do we use this data to affect behavioral change. Now, to link that, we need to make people aware, so they they want to change. And also to make them want to change, you need to motivate them. And the easiest way to motivate, people don't want to change generally, so to motivate them, what we need to do is make it easy for them to do it and give them a reason for it. Next slide, please. So we've tried to make an easy Chrome extension that you can download in Chrome. And so everyone goes to daft.ie if you're looking for houses. We all kind of have that in common. The housing is a very big issue at the moment. So if we can incorporate a simple plugin that as soon as you go to any listing, it gives you a kind of proximity of the air quality data. It pretty much saves you having to go to these external resources and right there for you, telling you exactly what the data is doing. I don't think we need those. Yeah, I think we're done with the slides, but the importance is we're trying to make an easy solution that it doesn't need you to go to external sources, that it's built right in, and if you want to learn more, you can, but to pretty much reach as many people as possible. That's it. Thank you.
That's great, guys. It's always good when people stick to time, so we're doing so well so far. So the next team is red light, bad, whatever that means. Yeah. Come up, red light. We'll all become clear, yeah?
So we're red light bad, and what we want to do is we want to empower users to avoid poor air quality exposure. So in looking at the cause, mitigation, response, effect bow tie, we're going to solely direct our attention to the kind of center. We want to look at where poor air quality has occurred so that we can empower the users to avoid it in the future. So how we're going to do this more specifically is we want to predict particulate matter 2.5 and NO2 by wrangling time, weather, and location. So I'm just going to show you 2 ways we have done that. So this is data from my citizen science air quality sensor in my back garden, and I just want to point out on Saturday evening that you can see there was a drop in the temperature, quite a sharp drop, and there was a corresponding spike in particulate matter. People started stoking the burning stoves, and it was pretty clear. Sharp temperature drop, plus a recreational evening, a Friday or Saturday night, in a known hotspot residential location, it gives a particulate spike. And why we're really confident about this is if you look what happened Thursday night, sharp temp drop, no particulate jump. So let's take that theory, let's apply that to the Acclima Project AirView data. So what we did in the first instance, and by the way, thank you, Joe, for getting us going in QGIS, we looked at the particulate matter and over the full time period, where were there known hotspots? And you can kind of see them highlighted here. And we also looked at NO2 to see where the known hotspots are. Let's zoom in on something quite close to us here. So we looked on one particular day on a Friday afternoon in June. And you can see principally the air quality around here is good. There was a bit of fizz, no froth. The Dublin Airport data, the temperature was nice and balmy. Now, my daughters and I would have been out with the kites that evening, there's no doubt about it. There was a lot of wind, but you can kind of see temperature, location, wind speed, good air quality. Let's look at, roughly speaking, the same location on a February morning commuting time, and you can see we're definitely getting particulate matter excursions. And it's same location, but look at the temperature and wind speed data. It's a bit cooler, slower wind speed. It's possible for us to correlate that there is meteorological influences plus known locations will result in poor air quality without us ever putting an air quality sensor in that location. And that's the value of the Acclima data just en massing over such a large area. Okay, so continuing with the kind of statistical analysis. On the left, if you try to average things out over a day, you're not really going to see correlations. But if you look on the right-hand side, hour-to-hour data, there is evident correlation between temperature and, for example, particulate matter, humidity, CO2. And it is very easy to correlate that these relate to each other. Okay, so what do we do with this? Okay, I think the first thing is, our summary is, locations plus conditions plus time does lead to air quality excursions. That much is clear. There are 2 groups we want to focus on in responding to this. So firstly, the technology companies. We want to empower users, and this is very similar to Hack the Hazes concept. you could give people alerts. If you're going out for a run using Strava, I go walking in the evening, your normal route is likely to experience poor air quality today. Reroute. Or good air quality is predicted, it's going to come up. Do you want Siri to switch off your air purifier device? And this is all without the users having their own €200 air quality sensor. So technology companies can play a big role in kind of enabling this, and I already see it with electric vehicle chargers routing in Google Maps. So this is a simple add-on. And then for the local and national authorities globally, what can they do? My simple summary is keep doing what you're doing with the nudge to sustainable transport, do it faster. And the one thing is with pedestrians going through spaces, and this is the meaning of red light bad, we need to hurry people through those spaces as fast as possible. And that is it. Thank you very much, folks.
That's super. I'm okay, thanks. That's great. Thanks, guys. Some great visualizations there as well. So thanks very much. So next team is Stranger 6. Stranger 6 wants to come up.
So, hi everyone, I'm here today to present the project that Stranger 6 have come up with. We're introducing the Green Navigator. This is going to be a tool for taking personal responsibility for the air quality in Dublin. This is the team, so we're a group of data scientists, transport engineers and students that have come together this weekend to work on this project. And the problem that we saw and wanted to solve. So the new data is great, obviously, but for most users, it's not very easy to use. We wanted to make it easy to use for everyday citizens. It's hard to make a greener choice without this information, and citizens and businesses with corporate responsibilities need help to take action to improve Dublin's air quality. So as a solution, we've introduced the Green Navigator app. This is going to be an augmented navigator, which takes into account population sensitivity, along with air quality conditions, and it will recommend green routes for drivers. So the data that we used, obviously the Google Project AirView data, and then we've incorporated census data that'll have population densities for particular areas, primary and secondary school locations. These are going to be areas that we want to avoid sending drivers into. Hospitals in Ireland, same again, and the route network from ArcGIS by Esri. So in order to make this navigator system, we've combined these factors to create a cost function that we're going to put over our map. The factors that we consider are PM2.5, NO2, school locations and hospital locations, population density, and there's an option to include bus routes and green routes in future development. Together, we're going to combine those factors and come up with a scaled cost factor for areas that we want to avoid in the map. So this is an example of it in action. We can see on the left the air quality data. We can see underneath are the population densities. So there's a red route in the bottom left corner over here, and you can see that it's in a fairly lowly populated area with high pollution concentration. So this isn't something we're going to be that worried about addressing. Whereas in higher areas coming into Crumlin, you can see the red route of high values of pollution, but that's coming through a really highly densely populated area, and that's something we want to reduce. So here we've come up with our cost factor, and that's the map you can see on this side. And you can see that it's going to prioritize the lower route that has a lower population density and avoid this red dot in the middle coming into a really highly densely populated area. So this is the score as we implement it across the entire Dublin City map. Red areas are ones we're going to want to avoid because of hospitals and schools. And this is an example of it in action. So this is going to redirect you away from the areas of problems, and it might take a little bit longer, but this is going to be a choice that we think that individual users can take to take on personal responsibility within the system. So in conclusion, we're using the high-resolution air quality information that's being made available. We're making it available via an app that people can integrate into Google Maps or something like that that they already use, allow people to take responsibility so citizens and policymakers can take action to improve Dublin air quality, and it'll provide support to individual users, and that's something that could be motivated by government actions that'll support green drivers using this app. And that's us. Yeah.
Nice. Thanks for that. And with Stranger 6, is that you didn't know anyone in the team before you started, or? No? Yeah, okay, just I was wondering the name. Anyway, no worries. The next team is a real novel team name. It's called Team Insight. Come on, Team Insight, come on down. Sorry, didn't mean to insult you.
Good evening. Today I'm going to walk you through our work, which is on a data-driven approach to air quality predictions in major cities. We are Team Insight and we're from UCD. First of all, why do we care? Air pollution is one of the greatest environmental risks to health. In 2019, 99% of the world's population was living in places where the WHO's air quality guidelines were not met. Two of the most dangerous pollutants to human health are nitrogen dioxide, NO2, and PM2.5. So we're going to focus on that. First of all, we want to get an idea of what can impact air quality at a given location. One thing we found from research, and then Team Red Light Bad convinced the audience of the same, is that weather can impact air quality. Air temperature can affect the movement of air, and wind can transport pollution. We went on to look at how the time of the day can also have an impact. So we looked at different locations, and we saw that normally around lunchtime or during the evening when there were more people moving around, the air quality seemed to be worse. We propose a solution which will allow us to make insights into the air quality of other cities. And we base this on ground truth data that we have of Dublin. We think this is quite valuable because the data that was collected in Dublin was a long time process. It took a long time to collect, and it was quite costly as well. So by getting insights using other data such as weather and time of the day and maybe traffic volume, we can help make interventions in other cities easier. So we put these features into an AI model, and we use that to predict PM2.5 and NO2. In our work, we focused on just some green areas, which we identified using OpenStreetMaps. We wanted to keep our data set smaller just to be able to give initial prototype. We mapped open source weather and location data with the given latitudes and longitudes. And with that, we were able to develop a model to predict NO2 in Dublin. The current best accuracy we have is 84%, and the confusion matrix shows the predicted labels against the actual labels. As our future work, we want to include the traffic volume as an extra feature. We'll need to do some more model validation and fine-tune our model. And finally, we want to use this model to make predictions in other cities to test our hypothesis. Thank you very much.
That's great. That's great, guys. I love to see happy photos of teams. It was really, really nice. So thanks so much, Team Insight. So next up, we've got Team Phoenix. Team Phoenix? Yeah. Wind down, guys.
Hello everyone, we are Team Phoenix, and for the past couple of days we looked at integrating hypergranular pollution data with vulnerability assessments to be able to create a decision model to help civil planners. So the Intergovernmental Panel on Climate Change defines vulnerability as a function of exposure, adaptive capacity, and sensitivity. In the context of air pollution, exposure looks at pollution levels and population density. Adaptive capacity looks at green spaces, vicinity to public transport, and active travel routes. And sensitivity is a means to understand that different demographics will react differently to air pollution. So we used a bunch of different open source data, namely socioeconomical statistics from CSO and raster data from Sentinel-2. And we've combined it with a variety of tools to get our results for Dublin. So here is our outputs for Dublin. You can see we've normalized exposure, adaptive capacity, and sensitivity so that we can compare one with the other. And interestingly, certain areas where exposure is high, sensitivity is not high. This underlines the importance of really combining the different layers to create a general vulnerability map.
So here's the vulnerability map that we got after combining all three layers, and that shows the distribution of vulnerability across different divisions in Dublin, and the values range from -1 to 1. The values on the negative side indicate lower vulnerability, while and vice versa. We used this layer further to do like a quick hotspot analysis to arrive at clusters of high and low vulnerability. And once we achieved this, we thought we can potentially apply it to something. And we heard that the Dublin City Council was planning a lot of active traveling routes. So there, 40% of their routes are still under consideration. That means a decision is to be made. So we thought, okay, let's try and apply this tool. So what we did is that we overlaid their routes, especially the ones that are still under consideration, and prioritized them based on the zones, the vulnerable zones that these routes pass through. So as you can see, the ones in green are the ones to be taken on priority, followed by the ones in yellow and blue. So this is just a demonstration to show, like, how this tool can be used to not only plan a new active transportation routes, but also for planning urban greening interventions and passive ventilation solutions. So as you can see, I mean, this tool not only gives you multidimensional insights, but also actionable insights, and therefore, it's time to act. Go Proact. That's the name of our tool. Thank you very much.
Thank you. Nice, really nice visualization. Everyone's doing a great job, David, with the visualizations. I hope you're proud of all the teams. So next team is Tech Trooper. Tech Trooper, can we come down? Yeah, come on, guys.
Hi guys, we're Team Tech Troopers, and basically our project is kind of looking at active transport users and to come up with the health benefits for them. So our city is filled with pedestrians and cyclists alike, but also sources of gases and aerosols that can transport all over the city. And these aerosols, these gases, they can be air pollution, and they can be transported to vulnerable communities, our active transport users. Health has a known relationship with pollution. Concentrations of air pollution have been linked with upwards of 3,300 deaths within Ireland. It can also cause, respiratory illnesses, things like asthma. Ireland's very affected by this because we have the 4th highest level of asthma in the world. That actually equates to about 380,000 people. So when we were thinking about our problem statement, I think the WHO said at the best, air pollution represents the biggest environmental risk to health. Could we mitigate that exposure to air pollution? Could we mitigate the exposure of our active transport users when they're trying to get from A to B? Could we take the green path forward?
Thanks, Steve. So we actually talk about, we actually heard about a lot of things about vulnerability, but we actually think about, we should think about the active transportation users. Because from the driver's perspective, we think about the road users are vulnerable. But from the active users' perspective, like pedestrians and cyclists, because we believe that they have already contributed quite a lot in reducing the emissions. So we need to do something for them. So that's why we come up with the solution. To further illustrate our project ideas, we have prepared a video. So let's hear the story from Sinead. Yeah, so this is just the system architecture. As you can see, that our systems consist of 4 parts. Instead of just reviewing what's happening for the data set, we also provide optimizations, and we developed both the front end and back end. So basically, if you used our apps, then you can know that what is the best road from now, and then go back to home. So let's look at a live demo for that one. So here we also consider the sensitivities of the different pollutants to the users. In this case, you can see this the pedestrians, and here you can see what's happening. Like you enter the starting point. So in this case, we have the Sparrow, and 2 is to the Dublin Castle, and then you click that, and then you take the start, and then it recommends you 2 routes, and one is the orange route, and another one is the green route, and finally it calculates what's the percentage of the pollutant saving that can give you. And we have achieved around 59%, which is quite amazing. Thanks. This is the team, and also like to thanks for the Google and Spot and Smart Dublin. Yes.
Hey, thanks very much. Thank you. They get extra bonus points for thanking us. Yeah. So I should have told that to everyone else. But so the last one, our second last, I think we're on now, Topologists Without Borders. So I thought that's a kind of an interesting team name. So Topologists Without Borders, go for it.
Thank you, everyone. My name is Silvio. It's an implied joke. It's not borders, it's boundaries, but there's no doctors without boundaries, so there's topologists without borders. So I was thinking about doing this in the urban planning section, because the problem that I identified, first of all, was that people thought this was a lot of data. Actually, it was barely enough data. And second, policy making is hard. Getting things done is even harder. So can we get something out of this that could be done by the month of May, in 3 months? And can it be significant, as in like you don't do it just for the sake of it, you're not greenwashing. So that's our problem statement. Can something be done in policy in 3 months based on this data? The additional data set I used is from a study done in 2014, which tried to identify heat islands in local microclimates in Dublin. The gentlemen who did it are there. They provided a methodology in which they classified tiny parcels of Dublin in the form of a grid up to about 0.25 square kilometers into what type of environment they are. And this was good because it saved me the trouble of doing it. But it turns down the line that actually it has some pitfalls. So if I move one more, then we took the data from Aclima and Google, and we assigned each of the data points at 1 second intervals to one of the squares we had classified. So this was the data enrichment process. And it is on in this level of the exercise where we discovered that people who tile a round surface in squares don't know what they're doing. So next time, whenever they do it, they should use hexagons. But I couldn't do it in the time. Really sorry about that. The methodology for this type of data is a dimension reduction process called topological data analysis. It was pretty sexy in 2013. It's mostly used in very high dimensional, multi-faceted data sets like the air of Dublin. We produce a topological model of it. It's a pretty map. It doesn't mean anything. What you care about is that it has 4 clusters of interest. And these are where we decided to focus, because the question is, can you do something in 3 months in these clusters that will actually help improve the quality of air at ground level in those areas? And you see the areas are pretty big. By the way, that map is a topological map. It's not necessarily overlapping with the Dublin map, so it doesn't look exactly like Dublin. And this is the idea we came up with. Where does pollution go when it goes? I don't know. But some of it can go up, and the higher up you go, the wind is more predictable, more constant. So we were thinking, what if we could actually make the particulate and the bad gases go up? There's good understanding of how buildings influence wind and draft. So if we turn this on its own, we can say that we can build a temporary light structure with which we can influence the microclimate and potentially change the pollution levels at ground level. So there's a whole part of math. I have some renders if you want after. We can use some designs for sails. If you went sailing, maybe you know what a spinnaker is. And we propose a Dublin urban sail that can be tested for about 200,000 euro, and we can actually measure to see if it has an impact and breaks the pollution in those areas. Thank you very much.
That's great. Thank you. Thanks very much for that. So now we're on to the last presentation. Wow. We're on to transportation junkies. So you guys are the last. So I don't know if we've saved the best for last. You're going to have to prove yourselves. But I hope everyone's enjoying the presentations. Just a bit of format. When we're finished this one, the judges are going to go off for about 30 minutes and deliberate. So you guys, looking forward to this last presentation. No pressure.
Thank you very much. Yep, so our team is the Transportation Junkies. And obviously, like everyone, what we noticed about the data set we have, it's extremely high spatial resolution. So we wanted to compare to other data sets with high spatial resolution. And so for that, what we did is we compared against the small area data from the 2016 census, where we have many hundreds of different categories we can compare against. And then we would use the same polygons that cover those small areas to compute the pollution inside those areas. We made important use of BigQuery in order to do this efficiently. And then we could ask many different questions depending on what we're interested in looking at, basically. So so this is the area. We have about 2,000 polygons that divide up the city, and we have about 500 people living in each one, and we can ask different questions like what we're going to look at in particular is how many children are there, or you could also ask about social, economic background and things like that. So first thing we did is we had to cut up all the polygons and then send it off and compare it to the air quality data set. What we chose to focus on was children, because what we don't want is lots of pollution in areas where there's also lots of children living. So here's a map, a density map of the children living in the city. In the middle, you don't see many children. It's more of a business district, and families tend to live further out in the city. Very few people live in Phoenix Park, it shows, which is good. It's consistent, at least. Then we take the air quality map and we just average the pollution in each of those polygons. So that's a big calculation, but thankfully BigQuery was able to do it for us very fast. And these are then this is where the more polluted areas are in the city. And then I'll hand it over to Killian to discuss the results.
Great, thank you very much. I'm already regretting the name we chose, but yeah, so here are the results of our analysis. And the red, so the dark red is basically where we saw a high correlation of high density of children as well as high density of pollution of NO2. So our use of this data would be to really look at these areas and find ways in which we can possibly improve the way it's planned. So one of the main concerns that we found is usually traffic lights. So cars staying idle in these streets really increases the air pollution. So either finding ways to reroute traffic or really creating an atmosphere in the city in which cycling, walking around, taking public transport is really incentivized. Great, so this is what the data we used to find a correlation between the traffic speed and the CO2 levels in the atmosphere, and there was a positive correlation. If you look on the left-hand side, 0 is when the car is idle, and yeah, we really saw that was what we assumed, but this is a proof of our assumptions. And really, the way we're looking at it is how can we use this data to either help Dublin City Council or look at the next steps that we could do with this analysis. So an interesting thing we looked at is looking at different points and areas within our maps. So here we looked at power, basically, yeah, power stations within Dublin, and looking at the levels of pollution. But this, we can look at schools, for example, Crumlin School, where there was a lot of construction, and see what's the level of pollution there. Is it really correlating with the amount of children? Because the children we've looked at where the children were living at, but during the day they'll be going to school, going to different areas. Well, okay, perfect.
Good stuff, guys, yeah.
Okay, folks, so what happens now is our judges are now going to go and deliberate on, they've got some hard decisions to make, obviously, with some fantastic presentations. Well done to everybody. You've done amazingly here today and over the last couple of days. They're going to go deliberate, so what we'll do is we'll just take a little stretch break here, and they'll be back to us shortly. So don't go too far, and we'll be back in to hear the results. Thank you. Yeah, be roughly around 20, 30 minutes. So take a stretch break and then come back in. Thank you very much.
Go. Okay, guys, we've got to that time now where we're going to announce the winners. And we just hope you had a fantastic couple of days. The presentations, I don't know about you guys, but that was just unbelievable. And we give yourselves a hand anyway. Really, you stuck the time, you stuck to the brief. Just really inspiring ideas and concepts, particularly from a city perspective in terms of what we can do with this data. Some really practical ideas. So really looking forward to following up with a lot of you here. So I know the judges had a really, really tough time. It was, I know that was hard to pick some winners today. So I'm going to ask, I suppose, two of the judges, Karen and David, to come up and just say a few words before we give out the prizes. Thanks, guys.
Yeah, thanks, Jamie. So it was a very difficult, hard decision and process, but it was made as easy as it could be by our DCC team. So thank you guys so much, DCC team. They made something that the scores could be added up instantly, and we could have a really fruitful conversation back there. So thank you guys very much, and for all of the preparation around the criteria and the prep for you guys, and then for all of you guys for reading it and sticking to it. Is awesome. It was a very hard decision. We wish we could pick all of you. You guys are all winners in our book, and I'm really thankful for meeting you and working with you over the last weekend, so I hope we stay in touch. Over to Davida.
Wonderful. Well, and I just wanted to say how inspired I am, and really want to thank all of you, because the fact that you showed up this weekend really helps us understand how we can put this data into the hands of the public and users to really drive change. So thank you for everything and for being here today. And just this weekend, a couple of things I wanted to say is that it was really great to see that there were solutions across all of the different themes. It was really diverse. So it's part of what made the judging so hard, and incredibly novel combinations of data and insights. And at the end of the day, the projects that were selected were ones that could immediately inspire actionable implementation and insights. And so it was an extremely, extremely hard process. And again, just want to say thank you to everyone.
Thanks.
And before we announce the winners, like, we don't see this as the end of it. This is just the start of it. And we're going to be in touch with all you guys. Maybe invite you to come back and network with us. We may have some drinks or something in the Mansion House if you're interested. And also we have ideas for how we can follow up and kind of build on some of these ideas. So if you're not a winner today, it doesn't mean that you're not a winner. You could still be a winner to us. And I think some of the ideas, working with different teams in our city council, like our traffic teams, our parks teams, there's so many different things that we can pull together on the back of this. So this isn't the end of it. And I know we're talking to Natalie and Karen in terms of how we can keep these ideas, keep these groups going. So that's really, really important for us. We also have opportunities where you can present some of these concepts back into kind of councillors and policymakers. So just if you haven't gotten the top three, it's not the end of it. There's some amazing stuff. And it's just the competition was so tight, it was really, really hard to choose. Choosing three was tough, like I think out of 16 or something like that. So anyway, keep going, keep up the great work, whatever happens, and we're really looking forward to keeping in touch with you guys. So next is for me to announce the winners. I'm going to start with third, and I've got a list here of the names here. Third place, so we're going to do a bit of a drum roll, is it? I don't know. Is that it? Go. A magic drum roll. So third place is Team Aeralytics. Woo! Well done. Fantastic. Good stuff, guys. Yeah. There you go. Well done, guys. Brilliant job. Great presentation as well. Great pitch as well. So, I'll do a photo here. Do you want to, what's the best way to do it? Like that? Yeah. Well done, guys. Well done, guys. Great presentation, great pitch as well. So now for second place, hope I got this right, yeah. Second place, actually I thought it was definitely the coolest team name. You kind of might know who you are. Definitely not ChatGPT. Well done, guys. Well done, guys. Fantastic, yeah. Here you go. Oh, brilliant. Well done, guys. Brilliant. Oh, it's a big team. Oh, fantastic. Oh, here you go. I'm going to take that one out. They had their jackets on to go because they didn't think they were getting anything. So well done, guys. So that's next is on to the first prize, and just I think all the teams stood out, but I think the one that came first really inspired us in terms of what they achieved over the couple of days and the potential that what they did could do for cities like Dublin City and other cities around the world. I know Karen, David, and the judges were really inspired about just the concept that they brought together over the weekend. And so the winner is Team Phoenix. Well done. Woo! Hello, guys. Amazing, yeah, great job. Well done, guys, fantastic, yeah. Well done, brilliant. Brilliant. Well done, fantastic, yeah. Well done, guys, you'll be delighted, yeah? So thank you everyone for coming here this weekend. Well done to the winners. Well done to all the teams who participated. Everyone here to us is winners, not just the top 3 teams. And I'd just like to thank everyone for making this such an amazing couple of days. I'd like to thank Google in particular. I know Anne-Marie is up there and her team who made this possible. People like Paddy and Neve, also my team, Dublin City Council. There's a lot of us being behind the scenes making this all work. And for all you guys, the hackers, you know, I remember a couple of weeks ago, we were like, I hope people turn up. Like, you know, we were wondering would this work out, but it's actually exceeded our expectations. I know Martin, you know, just from the city perspective and just, you know, your whole mantra was this data, this is only the start. And I think this is something we hope to see a lot more of. You know, people using data, helping the city, influencing policies and helping drive positive change for our city. So thanks everyone, and I hope you have a great rest of your weekend. Just a few things to note. The Google car is outside. I think, Anne-Marie, is it? I think if anyone wants to take selfies with the Google car. We got a group photo here, is that right, Frank? So if everyone wants to come down to the stage and take a group photo, and just a hands applause for everyone for what a great couple of days. Thank you very much.
Invite everybody onto the stage, please.
Yeah. And we get down for the
If we can invite everybody onto the stage so we can get a family photo, it'd be great. Thank you.